Hey guys, it's Mrs. Milton. Okay, let's do the last one for chapter 10. Okay, this is the scenario that we looked at where students take the SATs and then they took a prep class, and then they took the SAT again. Okay, so even though I'm looking at this as if it's two samples, it's not. This is one sample, okay, and the subjects did both treatments. They took the SAT before the prep test and after the prep test. So this is a matched pair example, okay? So there really isn't two samples to compare. So this really is not a two sample t-test, okay? These are means. This is actually just a plain old t-test, but it is for paired data, okay? So we'll get our state up here for a second. Let me put my plan in here. This is a t-test with matched paired data, okay? So let's do our ho and our ha. So what happened here? They took the test, they took the SAT test, they took a prep class, and they took the SAT again. So the mean improvement in their score was 63.2 points with standard deviation of 41.89 points, okay? Our interval, since they were both positive, showed that there is evidence for an improvement because 0 is not in the interval, okay? So I kind of want to say, I don't really have a mu to compare it to because what is the typical improvement of points? So instead, I'm going to do a mu sub d, okay? A mu sub d is the true population mean improvement or difference in SAT score, okay? True population mean difference, okay? But in this case, that difference is an improvement in SAT score after taking a prep class. Okay, well, if there was no difference or there was no improvement, mu sub d would just be 0. That means there was no difference, okay? Their scores didn't go up after the AP, after the prep class, okay? Or there was a difference, okay? I'm not going to do not equal to because since it was pretty high and my interval is all positive, I want to prove that it improved the score, okay? There was a positive difference, okay? Definitely improved the score. A negative difference would be the score went down. We don't want that, okay? My alpha, this was a 90% confidence interval, so we'll do an alpha of 10, okay? So this is very much just a plain old t-test. There's no two samples here. So when I do my conditions, I only have to do it for the one sample of students. So random, that's stated. Okay, independence. I'm pretty sure there's more than 300 students taking the SAT, right? And for normal, oh, thank goodness, I can use central limit theorem because my sample size is 30, yay. 30 is greater than or equal to 30 students. Okay, so my conditions weren't that bad. Okay, so now when I get down to the do, I can write this one out because there aren't two samples. So this will just be my mean minus the mu of my ho over the standard deviation of my sample divided by the square root of my sample size. Well, the mean of my sample was 63.2 minus the mu of my ho, well, that's 0. Standard deviation of my sample is 41.89 over the square root of my sample size. Okay, and if I drew this on the curve, I would set my mean at 0. Okay, so positive values will mean there was an improvement score, negative values will mean there was not an improvement. Okay, so of course my average improvement was 63.2, so I'm going to shade that way. Okay, throw this in the calculator, I do get a t-score or t-test statistic of 8.26, and I will throw that into TCDF. I'm going to go from 8.26 to infinity. Degree of freedom is sample size minus 1. So then I get a z-score of 2.08 times 10 to the negative 9. Let's look at that in the calculator just to see what it looks like. Okay. So stat test, and again, this is just a t-test. Since this was a matched pair data, I'm not actually comparing two samples. Okay. the mean of my hoe is 0. My sample mean was 63.2, sample standard deviation, sample size. The symbol of my ha is greater than. This one I will draw. This is a plain old t-test. Okay, I get my test statistic was 8.26, N and D, and my p-value is 0. Because you know what? That's really small. 2.08 times 10 to the negative 9, that's like a decimal with 8 zeros and then the 2. So this is pretty much 0, right? Good. So now I know my p-value is 0. It's going to be less than any alpha I have. So I know I'm going to be able to reject the hoe. Okay, so p-value against alpha. That is true. So the p-value is less than my alpha, and it is statistically significant. At the 10% alpha level. So I can reject the hoe. Okay, so if I reject the hoe, I do have evidence that there was a difference. Okay, as a matter of fact, it was a positive difference, which means the test improved. Okay, I have evidence that the true population mean difference in SAT scores is greater than 0. Okay, true population mean difference in SAT score after taking a prep class is greater than 0, meaning there was an improvement. An improvement in the score in the SAT score. Okay, so again, that is the same conclusion I came to from my confidence interval. Since 0 is not an interval, there is evidence for an improvement in the scores after taking the SAT prep class. Okay, and since they were both positive, students typically improve their scores. Okay. So again, I lump this in with the 2 samples, but it's not really 2 samples. It's 1 sample, and I'm looking at whether there was a difference between, it was a 1 sample matched pair. I'm looking at the difference between before the treatment and after the treatment. Okay? Okay. I hope this was helpful, and I will see you all next time.